Good morning. Yeah, I have the pleasure to co-chair this first session of the second day of the conference on public health and environment with Professor Aleko Mingo. And it is my great pleasure also to present the keynote speaker, Professor Melissa Perry, that is the main guilty of organizing this fourth now conference on public health and environment. I will just repeat a few words that academician Anila Hoda said yesterday during the ceremony of giving her the certificate of diploma of being appointed honorary member of Academy of Science of Albania due to his immense contribution in epidemiology, environmental health, and also on public health. So in world level. And Professor Perry also contributed a lot here in Albania concerning all issues related to environmental health. So today, Professor Perry will give a talk entitled The Frontier of Environmental Health, Exploring the Opportunities, Challenges, and Responsibilities of Artificial Intelligence. The floor is yours, Professor.
Thank you so much. Mirëmëngjes, shpresoj jeni mirë edhe jam shumë I gëzuar që jeni këtu. Good morning. I'm really happy to see you. So glad that you're here. I just want to make one comment about the Academy and what it's meant to be part of this organization. It's an extremely influential and important body that influences science for all of Albania. And from the very first day, I've felt extremely welcomed and encouraged to engage. And now here is our fourth conference. And yesterday is a strong indication of the kind of exchange and the kind of research and the kind of communication that you all are advancing in Albania and beyond. So it's a deep, deep pleasure. Unë jam plotësisht mirënjohës. Unë jam shumë mirënjohës. Faleminderit. So I was excited to talk to the group today about artificial intelligence because essentially we're hearing about it all the time, and it's very, very difficult to distinguish the hype, the overexcitement, from the reality. And so today, my purpose is to communicate some of the things that I've been learning about artificial intelligence and really to translate a more tempered and well-informed posture and position about artificial intelligence and what it can mean for the important work that you all do in health, in public health, in environmental health, and occupational health, and also in setting policy and policy protection around the natural resources for Albania. So my purpose is to really unpack the hype and distinguish the hype from the reality and the promise. So really my main thesis is that AI should be treated as a method for asking better questions, seeing patterns earlier and acting more responsibly, not as a substitute for environmental and occupational health expertise. And I think too often it feels as though existentially we may be turning over all ideas, all thoughts, all creativity to machines. And that is very threatening for all of us as humankind. So let's unpack that some more and really understand better what AI has to offer and the ways in which we, as a society and as a body of scientific expertise, get to decide how AI is going to be used. So why this moment matters. Environmental health is increasingly data rich. Been hearing about tremendous amounts of data yesterday. So many of you are working with large data sets, but so many of the decisions remain data delayed. And that is an ongoing theme in public health. It's an ongoing theme in epidemiology. And the reality is that machines that are now available can get us to a point of better data decisions. So the challenge in air, water, food, soil, climate, and occupational and agricultural exposures, they're measured across different places, times, and formats. For example, when you study pesticides, and as we saw in the global glyphosate study from Dr. Mandrioli yesterday, it's not one chemical at a time. In any one day, we're exposed to a myriad, a variety of different chemicals. And so the question becomes, how, as scientists, do we distinguish all of the various exposures, and how do we understand and quantify their health effects? The scientific opportunity is that we can integrate these heterogeneous data that reveal patterns, that prioritize risks, and support really early warning, if validated carefully. That's very much the caveat. That is the condition, if validated carefully. So we, as those scientists, practitioners, educators working in public health, we have new tools, and they have to advance equity, they have to advance transparency, scientific integrity, privacy, and public trust. Not simply, let's do it quickly, let's make decisions, let's quickly churn out data, and let's act on them. That's our responsibility, to utilize these tools with the utmost care and stewardship. So one of the big questions I want you all to think about this morning is, how can Albania and the Western Balkans use AI to strengthen environmental health stewardship while avoiding new forms of inequity, bias, and dependency? And this is what's so exciting about this moment and this opportunity, that we can seize these new tools, and we can make a difference in terms of how they're used. They're not something that are just going to be put upon us that we have to succumb or surrender to. So I wanted to give you a simple map of some of the major applications in artificial intelligence. In some ways, you've been using AI for most of your professional lives, the truth is, just simply by the way that we use computers, by the way that we use search engines, by the way that we use global positioning systems, our maps. Most of us may not know how to read a map anymore because we've become so accustomed to those devices such as global positioning systems and our GPS to be able to find our way. So you really can't live in today's society without essentially interacting with AI on a daily basis. It's just that something very big happened in 2022 that was life-changing, and that was the release of these chatbots that all of a sudden seemed as though machines were taking over. So let's talk about the different types of AI. There's rule-based AI that can use an if-then logic. That's very much similar to statistical programming that you set up to analyze data, and you say, I'm going to select this data set if it has these conditions. We've been using that in computer programming and statistical analysis for a very long time. There's machine learning. That is, you're programming a machine to make decisions, and then it gets better in being able to do that. I would argue that the advent of machine learning, with it came a tremendous disruption to scientific publishing. So for those of you who are publishing articles, our day-to-day lives now include multiple requests that are machine generated, that are attempting to bring us into publishing in various journals and also providing peer review. So I essentially remember when that started happening. And I would get all of these unknown machine-generated inquiries to say, will you publish in this journal? It was a rapid proliferation of scientific journals, and there was a rapid proliferation of distributing perceived scientific expertise, and it was a dilution of scientific distinction, I would have to say. So that was a major event in the use of machine learning tools, essentially to harvest, to market, and to do very, very aggressive, active machine outreach to individuals. There's also the deep learning neural networks that have been advancing for quite some time to understand complex signals. And then over on the right, the predictive AI forecasts risks or likely outcomes. One example is being able to estimate in the future where heat, PM 2.5, pesticides, or infectious risks may rise next based on prior data, be able to make projections and predictive analyses. Here, the generative AI is probably one of the scariest forms. It's the idea that it creates, summarizes, and synthesized texts and codes Examples are public draft advisories, summarizing literature, or creating plain language risk messages. And that's where you can prompt engineer, prompting being just like the request that you make of Google to find something. You now are asking generative AI for information. And it's profound and it's startling how sophisticated, how rapid, and how comprehensive generative AI currently is and increasingly is becoming. In addition to being scary, agentic AI is more of a dystopian vision in which you are telling the machine, do these things on my behalf, go shopping on my behalf, communicate with other people on my behalf, give me reminders on my behalf. That's essentially the vision of that personal assistant that is doing things for you, and you have transferred agency to the machine itself. So these are the various forms, many of which are very familiar to you if you've been working with data for the last 10 years or so, and some of them are rapidly evolving and advancing faster than I think most people were prepared. But this is to illustrate the evolution, that in fact it didn't all of a sudden happen with ChatGPT in 2022. It didn't all of a sudden happen. That in reality, the advancement of machines and computer generation of information has been evolving for quite some time, and some of the earliest stages were in the 1940s. The envisioning that a machine could generate a complex way of analyzing and making decisions. So I want to position this historically to say it wasn't as though we woke up in November of 2022 and said, oh my gosh, there are machines now that will take over whatever I do as a human being. It has been a steady and progressive advancement. And here you can see examples of where things were slow for a while. So this was the first winter where there was great interest in the 1940s. There was a slowing down of interest. Then there was a resurgence of interest in AI. And here we are in the current revolution, especially because of the advent of the chatbots and the release of ChatGPT. So try to keep that into perspective as though it didn't all of a sudden take over us. And in many ways, we've been using progressively sophisticated ways of how computers analyze data and how they interact in our daily lives. It's been absolutely inevitable. So some of you may have seen this curve of adoption. I think about this a lot. It really, really helps me in understanding where we are right now. Essentially, this can be applied to a variety of technologies, everywhere from the printing press to the clock to Google. You probably remember as professors asking yourself, should I allow my students to use Google? There was part of me that still wanted my students to go to the library and to be able to utilize a classification system and to be able to find a journal article in a book or on the shelf and copy that journal article. There was still part of me that held on. So when I think about this curve of adoption, I would say I tend to be in the late majority. Sometimes laggards, but oftentimes here. Something will come along, whether or not it was the personal assistant called the Palm Pilot, where you could put all of your contacts. I would move them from paper into a digital device to email. I can say I still haven't fully adapted to email. There's a part of me that detests email and would still say that I'm probably here. Maybe I'm in the late majority in terms of singing the praises of email. And when it comes to the smartphone, I didn't want anything to do with it. I used to come to Albania and we would go to the south, to my husband's village, and I would put that phone away, and I was so happy that it didn't work. I would say, I'm going to brick this phone. I'm going to put it away so I don't have to have this constant tug. So I guess I want to say to you that you may see yourself in these curves of adoption. In technology, I tend to be here. But what I've discovered at this stage in my career, that all of my resistance to technology has never gotten me anywhere. It has not stopped the advancement of technologies. Email didn't stop. iPhones didn't stop. The advancement of AI won't stop either, even if I sit on the sidelines and resist and critique and exercise tremendous amounts of skepticism and criticism. So in the AI space, I find myself more realistic and more practical as to how we're going to use these technologies for good. So keep that in mind as you think about what these opportunities are as it relates to AI. There's another curve that's useful to think about in terms of the time that we currently face, and that's what's called the hype cycle. That there's a new opportunity, there's a new trend, there's a new product, there's a new technology, and the question is, where will it eventually land? Is this just because of its novelty? It's just been released. There's a lot of buzz, there's a lot of excitement, but ultimately, where will it ultimately land in terms of productivity? So I wanted to share this with you as we think about AI, that here we are essentially in the innovation trigger when ChatGPT, for example, was launched in 2022. And this is kind of where we are now. I'm sure you're seeing plenty of articles about the existential threat of these machines that ultimately will be the end of humankind. I'm sure you've read about the dystopian visions for how the more we turn over our decision-making to machines, we're at risk of, there's a term called de-skilling. It's the same as me not remembering how to read maps anymore because I've become so dependent on GPS. It's the notion that I will allow the machine to do it. It not only does it well, it likely does it better than I do. So you allow the machine to do it, and ultimately you forget how to do it yourself. So there's a lot of concern right now, and I think it's healthy concern. I think it's legitimate concern. And I think we can navigate our way through the hype versus the pragmatism and the reality. And the message that I'll say a few times this morning is, this is our opportunity to make those decisions. This is not something that's being done to us. So we can ask exactly those questions of equity, stewardship, privacy, and protection, and ultimately drive what that future looks like. So I'm going to unpack 6 environmental health use cases for AI, environmental and occupational health. I wanted to show you a little bit about imaging. It's kind of where I started, how exposures can be modeled and how we rely on machines to model exposures, how machines can be used for early warning, how this can be applied to food and agriculture and food safety, how it can be a very powerful tool for surveillance, and also the prioritization of chemical risks. So this is work that I've been doing for well over 20 years now, and that is in cell imaging that allows me to understand abnormalities, especially in sperm cells. So it's a method that I developed in my lab at Harvard about 20 years ago. And when I first started, what I realized is that pathologists and analysts had to do the counting of sperm by hand. That was extremely laborious, very, very labor intensive. Oftentimes you would rely on graduate students to do this work. And I realized if I wanted to do large epidemiologic studies of a lot of men, then I would not be able to do this manually. So I started to look into computer-assisted methods. So this is just one simple illustration. It's sort of my beginning of recognizing, no, I really had to rely on machines, that I was not going to be able to do it myself. My lab members shouldn't be doing it themselves. And that the computer was as good, if not better, in identifying images. And that's when some of the greatest breakthroughs in AI have been made in the past 10 years. And that's in the diagnostic space, that there's a lot of subjectivity and irregularity of relying on the human eye to discern patterns that you can program out by ensuring the machine makes decisions precisely every single time, repeatedly without error, without fatigue, without distraction. And also you can go back. You've made a decision as a human, you can't necessarily go back. The machine makes a decision, you can go back and evaluate the validity of that decision. So this is just an illustration of how busy our slides are. These are a sperm, and then how we go through each of the nuclei in the sperm in order to identify chromosomes. It's spot counting, and we rely on computers to do so. I wanted to just use one of so many examples in the way in which AI is now being used for far more precise detection in cancer identification. And this was an example where one could essentially take a look at what was happening at a brain's cross-section, and then the AI was able to identify a mutant gene in one of the glioblastomas in the tumor of the brain. And this would not have been detectable by the human eye. And you're seeing that very consistently in radiology, in mammography and breast cancer identification. And I guess if you think about it, it comes as no surprise that you can train machines to do this better than humans. It's threatening, it's scary, and it's not something you just hand over and say, I will just pay attention to the machine and remove the human from the whole decision making. But you can certainly be augmented and supported by the machine. We've talked a lot yesterday about exposure mapping. You can see from a sparse data set, you can start to identify spatially richer exposure estimates. So using AI and machine learning, you can start to generate surfaces and hotspots. You can utilize and integrate ground monitors. We heard from Dr. Barai yesterday about the ground monitor analyses that he and his team do. But imagine being able to take the patterns of those data and ultimately create exposure maps that are multifaceted and multivariable. So satellite instruments are very, very powerful source of data and information, but it's not as though the human could assimilate and synthesize all of it on our own. The images estimate gas and particle levels. Their main advantage is spatial coverage. You can look at very, very big areas, and then it can help you identify pollution hotspots, trends, transport, and exposure gradients. And these exposure scientists, these air pollution scientists, would be the first to explain that their tools are these increasingly smarter, more sophisticated machines that can make decisions. But those decisions are based on human input and human programming. Just as I showed you the imaging that we did with the sperm cells, it was the information that we told the machine on how to make these decisions that ultimately began its path of improving classification. So with that, back to the local, models really have to be calibrated locally, and that satellite data are not a replacement for ground monitoring. There's a real complementarity of this information, and you want to cross-validate and corroborate the information as well. Another example is in the early warning space, that pollution measurements often happen after exposure. But imagine understanding the precipitating events that are creating a moment of sentinel opportunity that ultimately would anticipate major climate events or air pollution events in advance of them actually happening. In some ways, you learn there are predictable patterns, but it's going to take more than a few good minds to be able to identify those patterns. It's going to take the high performance computing of machines to be able to allow the identification of patterns. So AI-enabled opportunity means real-time sensors integrated with satellite observations, integrated with weather, traffic, and health signals to forecast an early action. And then similarly, in terms of action, imagine targeted alerts. This was mentioned yesterday that we could have, ultimately in Albania, we could have an air quality index. We could have an ozone index that could better capture all of the input that you currently have and strengthen and increase the data censoring that would be specific to Albania. So pollution control interventions, and that could be tested and evaluated. So we're really trying to get more timely, more comprehensive, and actually more anticipatory as to how these extreme air pollution events occur. So I thought this was a great example of some very, very useful data. And again, I was thinking about it yesterday as we were talking about air pollution. So this is a recent study that was published in Nature Communications. And it explained how it was possible to utilize 9,500 ground monitoring stations worldwide. This was an effort to capture an entire analysis of all air pollution across the world, covering every single bit of land. So 9,500 ground monitoring stations, that the grid of each of these monitors was about 1 kilometer, that this was 6 years of daily estimates. No human being is really ever going to be able to process that efficiently on their own, and that there was 100% gapless spatial coverage over land. Meaning to say, with those 9,500 monitors, 1 kilometer range, they were able to blanket and cover all of land in the world. And what they found is that 96% of areas experienced at least one day in 2022 that was populated, that was above the WHO guidelines, at least one day. 82% experienced at least 1 week, and then 53% experienced at least 1 month. These are regions in the world that are experiencing extreme air pollution according to WHO guidelines. So integrating monitors, satellites, weather, context, utilizing machine learning algorithms that takes a lot of data that are noisy and that are multifactorial, and ultimately producing maps, hotspots, epidemiology, and policy. I think it would be exciting to take a look at that paper more carefully to see what was understood about Albania. Because here we are struggling without any ground monitors, the regular details of which are no longer available, that I really think has to be addressed. And it was captured ultimately in the satellite imaging. So it's a beautiful, elegant example of how you can take a massive amount of data, messy data, noisy data, and turn it into a full, clear picture. But I wanted to emphasize this message about equity, that equity lens, a high-resolution model can reveal hidden exposure gradients, but only if data gaps, bias, transparency, and community relevance are actively addressed. So I can tout the praises of these wonderful models and machines, but there are many, many gaps that have to be attended to as well. Here's another use case in the water, food, and agriculture space, everywhere from sensors and machine learning to support continuous monitoring of water quality. In terms of food safety, I know the hard work that has been going on or in the past for sure, and continues in Albania around understanding the safety of food produced in Albania or imported from outside, and being able to study pesticide residues, mycotoxins, and other contaminations. And then agriculture and precision agriculture. However, too often you will see the technology promoted and touted as this is the best next thing. But too often what's missing is what are the environmental impacts and what are the human health impacts of whatever technologies are advancing. So this has to evaluate exposure consequences, not only productivity. That's often missing in agriculture. This is a simple illustration of surveillance. And as I was thinking about Professor Mbylli's presentation yesterday in non-communicable chronic disease, there are some real fundamentals here related to the layers of data that are now available, the integration of exposure and health outcomes, the synthesis in AI analysis, and then ultimately the preparedness to better understand how surveillance models are going to strengthen the specificity, the timeliness, and then also the false alarm consequences as well. This one is near and dear to my heart and to my colleague, Dr. Mandrioli, and that is in systematic review. The question constantly becomes, well, we've studied this. We have studied this particular mineral. We've studied this metal. We've studied this pesticide. We've studied this pathogen. It's been studied for 5, 10, 30, 50 years. How do you synthesize all of the information to this point to better understand what the status of the evidence is and to better make accurate predictions and overall epidemiologic insight? Well, AI systems allow you to upload and to integrate massive amounts of literature to make a synthesis and analysis of what the literature is ultimately saying. But again, the message is human in the loop. You can remember that phrase, human in the loop. It's not optional. That expert review, transparent workflows, reproducibility, and validation remain essential for credibility and policy relevance. So it's not a surprise that we, if we're embarking on a systematic review, will utilize machine systems or even companies that can do this for us. But ultimately, it is the expert assessment to evaluate how accurate, how timely, how relevant the information is. I wanted to also say there's so much conversation about how AI will remove jobs and machines will replace humans. Everything I can see from these case studies simply mean that the skills that you need to engage in AI are evolving, and in some cases, more humans will be needed. That it is unlikely that we will reach the time in science that we will simply say to a machine, assess the status of this problem, solve it, and publish the results. There will also always be a critical need for experts and expert judgment to be part of each step of the way. But the AI tools will allow us to command and to leverage massive amounts of data to better inform these decisions. So keep that in mind. It's not so much will the scientist be replaced? Will the educator be replaced? I think the real question is, how will human decision-making be essential for the advancement of these tools? So here's a practical opportunity for Albania. These are some key areas and themes that I know many of you are working in and also have been themes as part of our conferences this year and in years past: in air quality, in agriculture, in occupational health, in water resources, in climate health, and in public health systems. Those are the essentials of a comprehensive environmental and occupational health strategy for a sustainable future for Albania. And each one of these contexts, you can really see. There's a quote by a famous science writer, and his quote is that the future is here, it's just unevenly distributed. And what I mean by that is that so many of these applications are already happening or are being demonstrated or being tested out. So this is a chance for all of you as scientists and educators and practitioners to really seize this moment, to be a part of it, to acquire as much information as you can, and then to exert your expert advocacy, decision-making, and evaluation of these systems. So again, the themes of equity are essential: equity and bias, that the most exposed must not be the least visible, and that too often, because of algorithms that have bias that are based on prior information, if you have not paid attention to the Roma, let's say in northern Albania, and there's no information about them, these AI systems are not going to solve that. I'm just using that as an example. If you've not paid attention to children in a lot of the data that have been collected in Albania, we're not going to solve that because so much of the data are based, so much of the machines are based on what data have been generated previously. So understanding where marginalized groups have never been measured, they're going to be absent in your AI algorithms as well. And then also the idea that equity first is designed. That's where it feels as though so much of this is scary and mysterious because it's being driven by technology companies rather than community members. But I would propose to you that community members can be as much a partner and have as much to benefit in being able to leverage these technologies than any tech company. So we flip it on its head and say, imagine these tools and technologies being used for good. And that's been a constant theme in public health for as long as I've been in the field. So who is represented in the data? You always want to ask that. Who benefits if the model works and who is harmed if it fails? How will communities know, question, and challenge model-driven decisions? And does the model improve outcomes for the most exposed populations? Those are fundamental questions, very easy to overlook in all of our excitement by the hype and the speed and convenience of the models. So I think that at this point, it's an ethical issue as well, and we move from innovation to trust in terms of transparency. I'm very concerned about the commodification of data. That really happened during COVID. I had a heck of a time getting good COVID data in Albania, let me tell you. And that was true in the US, that too often, because data were being generated by